Take a front row seat as forward-thinking speakers open your eyes to the latest innovations in the maritime world and a fresh perspective. The future is now. Welcome to VriThink's Night Out.
Yes, well, thank you. Well, my name is Romijn, and I'm the former team captain of the DB20 solar boat team. And today I want to share our story about how we developed our own carbon fiber propeller. But before I continue with my story, I want to tell you about the team who made all of this happen. The DB20 solar boat team consists out of 7 young engineers who all have a passion for green technology. Each of these individuals in this team has its own specialty, such as mechanical, electrical, and marine engineering. And together they decided back in 2015 that they wanted to work on the DB20 solar boat. And what is this solar boat? Well, basically it's a race boat and an innovation platform in one, with its entire deck filled with solar panels, which it uses to collect energy as its only source. But in order to use this energy as efficient as possible, the boat flies above the water, therefore reducing its drag as much as possible and being able to speed up to more than 35 kilometers. But of course you have to race with such a race boat, and that's what we do throughout the entire of Europe. We race against other young individuals who also have the same passion about solar boating. And so we compete to each other, but this competition can be hard sometimes because we always want to win. And in order to win these races, we have to outsmart each other and come up with new solutions and ideas. And one of these solutions we came up with was our carbon fiber propeller, and that's what I'm going to talk about today. So, before we want to race with these propellers, we first need to build one and, of course, design one. And designing such a propeller can be quite tricky sometimes. There are a lot of parameters you have to take into account: material strength, RPMs, engine torque, power, speed, etc. And to make this process a bit easier, we decided, okay, let's turn all these decisions we have to make in this process into an algorithm. An algorithm which takes up all of these parameters and turns it into a CAD model. Not only optimized for performance, but also for material usage and material strength, because it has to be structurally well. So, as soon as this algorithm is finished, we do not only get a 3D CAD model of the propeller, we get more. We also get a bill of material. What materials do we need for this propeller? But also a spec sheet containing the expected performance of the propeller. And finally, one of the most nice things we get is the 3D CAD model of the molds we need for the production of the propeller itself. And this turned out to be very important, because we needed to speed up the production process in order to make it compete with aluminium CNC milled propellers. So after many trial and error, we finally succeeded, and it was a big time, because then we were competitive with the conventional techniques. So after all this was finished, we were very happy. We finally had our carbon fiber propeller, and we could finally start testing it. And this testing turned out to be very important. We learned a lot of lessons about it, because one of the first things we expected to be the hardest part was actually the blade. It needs to be efficient, it needs to be strong. But in the end, it turned out that actually the hub, the center of the propeller, where all the blades get connected, was the hardest part. One of the first things we thought, let's just glue them together. Well, this was one big headache, because it wasn't strong enough, and it also took a lot of production time. So in order to speed up this development process, we decided we need more data. Data about speed of the engine, torque of the engine, when does it brake, how does it brake. But all this data, weather conditions, you name it, we got it. In order to collect all this data, we needed some sort of system. And of course, the solar boat isn't really standardized, so we need to develop it ourselves. So we took some custom PCBs, and they collect all the data for us. So once the data is collected, it gets stored, uploaded to the cloud, and there it is being analyzed, creating a whole new digital twin of the DB20, in which we could simulate the entire boat. And this data became very important, because now we knew the exact behavior of each component in the boat. which created a lot of understanding about what was happening under the boat and with the propeller. And this was really a lot of learning we could really use to improve the development of the propeller. We could match up theory with reality. But while doing this entire process, it wasn't only about how to design a propeller, it was about more. We also learned a lot about composites, programming, cloud computing, digital twins, etc. But luckily, we didn't have to do all of this by ourselves. We had a lot of partners, friends, and other teams to help us with this development process in order to speed all of this up. And that's something we're really grateful for. And that's why we want to continue this line and want to make this entire project open source so that everyone can benefit from our lessons learned and implement them for themselves. Well, as mentioned before, we're currently in a testing phase. And as you can see here on this picture, it's still in a testing phase with one of the other solar teams, which is using our propeller. We really created a win-win situation here, because they get a propeller to sail with, and in return for this, we get a lot of data and experience with the propeller. So, now we're testing. What's next? Well, one of the things we want to work towards is to use biocomposites as a material for the propeller, different material properties, and all those kind of things. And this way, we open up a whole new design challenge for us as a team and as engineers to work towards. Well, and of course, the hub. We did a lot of improvement and spent a lot of time on it already, but we still believe it can be better. And one of the ways we think it can be better, it has to be smaller, it has to be stronger, it has to be stiffer. You name it, we want it better. And with having that said and looking towards the future, I'd like to end my story about the development of our propeller for today. If you have any questions, please never hesitate to contact us. Thank you for your attention.